Hi, welcome to part 4 of the course. In this part of the course, I'm going to talk about regression analysis. This topic may be a little bit advanced for beginners, but at the same time it is also a popular approach if you want to analyze the relationship between two variables, usually two scale variables. So I'm here going to give you a brief introduction to the concept of regression analysis and also how to do it in SPSS. The simplest form of regression analysis involves two scale variables. As shown in my example here, one variable is x and the other variable is y. So when you try to plot the x and y on a graph paper, each pair of x and y gives you the coordinates of one data point. And in my case here, I have a total of 10 pairs of xy coordinates, and so I have 10 data points in the graph. So that's the easier part. A more difficult part is to find the relationship between these 10 data points. Or in this particular case, we want to fit a straight line into these data points so that the straight line represents the trend in the data. But of course, we don't have perfect data, and the straight line will almost never goes exactly through all the data points. Some of the data points will be above the line, and other data points will be below the line. So what we need to do is to find the line of best fit. And in a more mathematical term, we want to minimize the error between the line and the data points. Now it turns out that this is a mathematically well-defined problem, and it has also an exact solution. But I'm not going to go into the calculations here, but instead I want to show you how to do this in SPSS. So let's begin. Here I've already entered the data into SPSS. And the first concept I want to introduce is the correlation. The correlation means the linear relationship between the two variables. Or in other words, when you plot these 10 points in a graph paper, how much do they look like a straight line? The correlation is usually denoted by the symbol R, and this R can go from -1 to +1. If it is close to -1 or +1, we say that the two variables have a strong linear correlation, or in other words, they fit very good at a straight line. And the difference between a correlation of +1 and a correlation of -1 is that for the positive correlation, the variable y increases with variable x. So in a graph paper, the line goes from lower left to upper right. Another way to say this is that the slope of the line is positive. Now on the other hand, for a negative correlation, it means that y decreases as x increases, and the line goes from upper left to lower right. Or we say that the line has a negative slope. Now on the other hand, if the correlation is close to 0, either from the positive side or from the negative side, it means that we don't have a strong linear correlation. Or in other words, the points do not look like a straight line at all. Now let me show you how to do it in SPSS. In the SPSS, you can click on Analyze and then find the Correlate. Now we are dealing with the simplest case of linear regression, which means we have only two variables, and the mathematical term for this is bivariate, which means two variables. So we click on bivariate, and we put both x and y into the variables on the right. And down here, in correlation coefficients, we are going to use Pearson, which is the R I've been talking about, and it is suitable for the case of two scale variables. If you have other situations, such as two ordinal variables, you can try the other options, but I'm not going into the details here. So we just click OK, and here's the result. So this table basically means that the correlation between x and x is 1. This makes sense because a variable always has perfect linear correlation with itself, and the same is true for the correlation between y and y. It is also 1. Now what we are interested in is the correlation between x and y, which is given by the 0.976 here. So this number is very close to 1, which means that x and y have strong linear correlation. It is not perfect, but a very strong correlation. We don't usually have such strong correlation in real-life data. Usually, if we have anything greater than 0.7, we already consider it a strong correlation. And if it is something close to 0.5, we say that it has a moderate linear correlation. And if it is around 0.2 or 0.3, we say that the linear correlation is weak. But this kind of correlation is also quite common in real-life data. Now, of course, if you remember what I talked about inferential statistics in part 3, we are usually not satisfied by the descriptive statistics. Instead, we try to draw conclusions about the population data. And in this case, SPSS has already done this for you. In the second row of the correlation table, you see SIG. Again, this is the p-value. And this p-value tells you if the correlation you find above is significant for the population. So here the p-value is displayed as 0.000. Again, it is not really zero, but it is so small that you don't see any non-zero digit in the first 3 decimal places. And if you look at the 2 stars here, or 2 asterisks here, it means that the correlation is significant at the 0.01 level. Now down here we also have the correlation between y and x. Now of course this number is always the same as the correlation between x and y because the correlation is a symmetric concept. The correlation between x and y is always equal to the correlation between y and x for any 2 variables x and y. So this is what we get from the correlations. But this is not yet regression analysis. In regression analysis, what we are interested in is not only how well the 2 variables fit into a straight line, but more importantly, what the straight line looks like. And mathematically, it means we want to know the mathematical equation of the straight line. Now, if you remember what you learned in your high school mathematics, the equation of a straight line has 2 numeric parameters. One is the slope, and the other is the y-intercept. If you know both of these parameters, then you know the equation of the straight line. And if you know the equation of the straight line, you are done with the regression analysis. So let's see how to do it in SPSS. There are actually more than one way to do regression analysis in SPSS. And I'm going to show you the ways that I think are simplest for beginners. So the first way to do it is to click on Analyze and find the regression menu. And on the right, in the second option, click on the Linear. And to conduct the regression analysis, you need to specify the dependent variable and the independent variables. The dependent variables is the variable that depends on other variables. And in this case, we assume that y depends on x. So y is the dependent variable, so I put it into the dependent box here. And x is the independent variable, so I put it into the independent here. So that's all. Now let's click the OK button. And here's the result of the analysis. So let me highlight the information that is particularly useful. Now in the second table, you have the model summary. And in the first column, you have the R, which is the Pearson Correlation. And it is shown as 0.976, which is exactly the same number as we found earlier above. This must be the case because they are actually calculating the same quantity. And then next to the R here, we have R squared. Now R squared is the square of R. And in regression analysis, people usually look at R squared instead of R because R can be positive or negative. But R squared must always be positive or 0. And next to the R squared, you have an adjusted R squared. If you're trying to compare several different regression models, when there are more than one independent variables, or in other words, you do not only have x, but you have x1, x2, x3, and so forth. And we call that multiple regression. But I don't want to mess up with multiple regression in this introductory video, so let's ignore the details. And here we'll just look at the R squared. This number goes from 0 to 1, and if it is close to 0, it means the 2 variables have a weak or no linear correlation. And if it is close to 1, it means they have a strong linear correlation. So you can consider the R squared as a measure of the goodness of fit of your regression model. Or in other words, from the R squared, you can tell how the straight line fits into your data. Now I will skip the ANOVA table and scroll down to the last table, which is about the coefficients. Now for a straight line, we have 2 parameters. One of them is the y-intercept and the other is the slope, as I've explained before. And in SPSS, the y-intercept is given by the unstandardized b. B is a symbol for the coefficient. And in the front, you see constant. Constant means that in the equation, this number is not multiplied to any variable. Or in other words, this is the constant term in the linear equation. And it represents the y-intercept. So the y-intercept is 10.363. And the next one, you see the variable x here. And the number 4.097 means the coefficient, or the number multiplied to the x in the linear equation. Or in other words, this is the slope of your straight line. So that's how SPSS tells you about the straight line. It gives you the 2 coefficients, and in addition to that, we also want to look at the p-value, as always. Now the p-value is in the last column. Now here the p-value helps you determine if the corresponding coefficient is different from 0 if you are considering the population data. So in my case here, the p-value for the constant term is 0.001, which is much smaller than 0.05. The null hypothesis here is that the coefficient is equal to 0, and the alternative hypothesis is that the coefficient is not equal to 0. So here we know that this constant term is significant in the population data. And the same is true for the slope or the coefficient of x. The p-value here is 0.000, again too small to show any non-zero digit. So the conclusion is that the slope of the straight line is also different from 0 in the population data. Now this conclusion is particularly important because when we conduct a regression analysis on y against x, as in our case here, we are usually interested in how the x affects the y. Does the y changes with x, or is y the same no matter what x is? The later case is true if the slope of the straight line is 0, because a straight line with slope 0 is a horizontal line, and no matter what x is, y is always the same value. Or in other words, although x and y may have a perfect linear correlation, which means they may fit very well into a straight line, but if the slope of the line is 0, it means x does not have any influence on y. And we want to know it if this is the case. So that's one way of regression analysis in SPSS. But in many cases, we also want to see the data points and the straight line in a graph. And in order to do that, we can click on Analyze, go to Regression again, but this time we choose the third option, Curve Estimation. Now you know what a curve means, but mathematically, a straight line is just one special form of a curve. So what we do here is to put the x into the independent variable, and then the y into the dependent variable, and then down here, we've selected linear. Linear means straight line, which is what we are going to do. But in other cases, people may also want to fit other curves into the data points. For example, quadratic. Quadratic means you do not only have a constant term and an x term, you also have an x squared term. And if you plot a quadratic equation in a graph, you get a parabola. So basically, if you choose quadratic here, it means instead of using a straight line, you use a parabola to fit into the data points. And we also have other different curves, such as cubic. Cubic means you have x cubed terms, and so forth. But now we're going to stick with the linear, and so we just click OK. So here you have a few tables, and then in one of the table, you have the r squared, again, the same value of r squared, and you also have the two coefficients here. This is the constant term, this is the coefficient of the variable x, or the slope. What is different from the previous analysis is that now we also have a plot. And here you see the data points here and also the straight line. And the equation of the straight line, although it is not shown here, is actually y equals 4.097 times x plus 10.363. And if you look at the y-intercept here, the intercept this point is slightly above the number 10. And in fact, this is just 10.363. So this is the second way of doing the regression analysis. You don't have that much detail about the p-values of the two coefficients, but you have a graph, which can be more useful in some situations. Now, the third way I'm going to introduce to you here is to plot the graph directly. So what we do is to click on the graphs, and then Chart Builder. Here is again asking you to set your measurement level properly. And in my case, all the variables are already properly set, so we can just click OK. So what we do here is to go to the lower left-hand corner and select Scatter, because the graph we are going to plot is called Scatter Plot. And then we choose the first one, drag it to the area above, and then drag x into the x-axis and y into the y-axis. Click OK. So here it is. You see the data points, which are the same as the data points that we've seen before. But we don't have the straight line yet. And in order to have the straight line displayed in a graph as well, so what we do here is to double click on the graph, and then in the chart editor, we click on Elements, and then Fit Line at Total. So once you get to this dialog box, you already see a straight line given to you automatically. So you can just click Close, and here's the result. Now you see the r squared value in the upper right hand corner, which is again the same value, 0.952. And the equation of the line is displayed in the middle of the graph. So that is the third way you get the regression plot. But this time, SPSS doesn't give you any p-value information. So here's how you do regression analysis in SPSS in 3 different ways. In the first way, it gives you more detail about the regression. The second way, it gives you less detail about the regression, but it gives you the graph with the data points and the straight line. And in the third way, basically, we are plotting a graph, and we are not given a lot of information about the regression, but we have the equation of the line and also the R-square displayed in the graph. So that's all for regression analysis. So thank you for watching. See you in the next video.